Hi everybody, welcome to the third class about the fourth track, how to apply artificial intelligence techniques on the container port logistics. My name is Anibal Azevedo and now we're gonna continue from the previously class. If you didn't see the previously class, it will appear as a car somewhere. And finally, we can use the initial population that we made in the previously code, and also, it's important to understand how we can evaluate each individual, each random individual that we create in the previous class. So let's start code. And okay, so now we're gonna need the previously tracks developments. Remember that in the description of this video, we have all this code. So we're gonna activate this. So we click it here. So we are connecting in the Google Colab. We are initializing the Google Colab. Okay, we are now connected, and the code contained in the cell is running, so it's okay. So after running this, we need to load also the unloading and loading rules functions. Let's okay load them. So this all these codes are right, but it's running. So we are also performing some tests to see if the code is correct, or if we have something that's not good. So after running this, we need also to load this, okay, this cell. And after doing this, all these cells, we're gonna need each cell. Remember that here we define the container ship class. Here we define the unloading and loading room functions, and here we define the port simulator. Okay, so you can see here the cells we are loading here. Okay, so the unloading rule is here, and I don't know why the unloading rules take too much time to run. We have tested this on previously class, so this they already run. Also this and this. Let's start again. I don't know why this happening. Stop this. Okay, it's performing very weird here. I've never seen something like this. So it's okay. It's loaded. Okay, so it took time to just to draw. I don't know why, but it's loaded, and finally we can use this port simulator. So it's running also this, and after doing this, we have loaded all necessary code for your evaluation. Remember that this third track we defined many interesting and important functions here that will enable us to evaluate each combination of rules in simulation. Yeah, okay. So it's just finished. It's just correct. Loaded all things. So an important thing that we made in previously class is to define an initial random population. So this is the number of combination of rules. And after this, we created this. Uh, okay. Okay, number of ports not defined, so we need to define it. So let's start here. We don't need to rush here. Okay, so okay, now it's so correct. Everything's correct, and we can now start to develop our things. So imagine that we get this individual. We are interested to evaluate this individual. So how we can evaluate this? We can use the code that defined in the CS container ship simulation, and just to test things, we can get all this configuration. So this is the right configuration. We are trying to configure, to build the configuration or to use this configuration because the simulation needs some parameters. So we defined here. Let's see these parameters in detail. So first we defined the container ship space, the number of bays, the number of rows, and the number of columns. We defined also the number of unloading and loading rules that we can apply in this container ship through ports, through the ship travel through ports. And also we have the transportation matrix here. We can use just false to avoid a lot of messages and uh, draws of the ship, so it be more faster to simulate without the verbose mode activated. And here we can define the number of ports as 4, and the number of bounds here we can use it 12. It's more general if we use not this, but use this any prod. It will be more general the code if we use this function instead of just declare the number, and this number will be computed by doing this. Okay, so it's more general. I believe that the code will be more general by doing this. So instead of doing this, I believe this 12 not good, but this it's much better now. Okay, so after doing this, we can perform. We use these parameters to configure the simulation, and after this, we can use this solution. We can print this print solution, not print, but print the solution. And finally, we can get the total number of movements for this possible solution. So we got here. So let's start to see what happened. Okay. So this is not correct since we try to evaluate by doing this. Okay. Let's see what's happening. Oh, it's not right because we forgot to do this. Okay. So now we have this list of rules that we should apply for each port. So it's evaluating. And finally, we got this message, which is not good because because the transportation matrix have just 3 ports, not 4. So let's try it with 3 ports. So it's okay now. Remember that the number of lines should be the number of ports. Okay. So we just forgot this. Let's the variables moves. It's not good because we are just showing this. We should correct this. But it's okay now. We got the number of movements, the total number of movements. Also, we got this. It's not good because we should correct the verbose mode. The verbose mode is off, but he's still are doing some um, printing outside. So let's see. Okay, here we can comment this or put in the verbose mode. It's up to you to see the back. What else we have here? Okay. Oh, it's also here. So you can use these variables here and if here. I can use also here. So now We are should reload this. It will take a time, but it's interesting because now the verbal osmosis, if it's off, we will never see any print or message. It's not good because it will take a lot of time to see the. Okay, now it's much faster, and we see just the number of movements. That's the thing that we it's good to, for us to perform some tests. So here you have this variable pop, and we are interested to see if this individual it's better than this one. Okay, I know that it's not good because we have too much ports, more ports than we should have. So we can fix this by doing this, and finally reload the initial population. Okay, so now we have the correct number of dimension for each individual, and we can test. Let's see if this individual is good or not, or it's better than they have a lower number of movements. So how we can do this? We can just take one individual. How we can take one individual? Just use some index starting from 0, for example. And after doing this, we can store in a list. We can store in a list. Let's start an empty list. And this list, we can append the result of evaluating an individual. So we can use this simulator, the function evaluate, and just evaluate the individual and see what happened to this empty list. So we got also the number of movements equal to 17. So here we have some interesting thing because we can also create some kind of loop where we can evaluate all individuals and store in this kind of list. Okay, so let's try this for starting now. There is a more efficient way to do this. You can do this in one line scores, for example. Will be a list which from the result of evaluate D for D in pop. So this is a most interesting thing because in one line we avoid a loop, we avoid to pick up each individual in this list of individuals, and we got all the scores. Okay, so let's try it. So it's perfect because instead of using a loop, we said, okay, so you should apply for each individual in pop the system evaluate each individual in pop and store all these results as a list in this variable scores. So it's perfect. We got all 17. And if you want to do something, some operations using this information, for example, if you want to select some specific solution based on this information, we can use it. And this will be very, very useful for operations like mutation and crossover, or even selection. We're gonna define in the next class a selection function, and this selection function will look at this score and see this score is better than the score of another individual. So select this individual will have a higher probability to be selected for the next iteration or next generation, and we can select it more frequently this individual for operations like crossover or mutation, which will change slightly this individual to find a different individual which can be worse or better than this actual individual. So this is the thing. This information will be very, very, very important for the next classes because it will serve as a parameter for selection or just to take the individual and make some changes and to produce better individuals. Even sometimes you can produce worse individuals. But is the paper of this function evaluate apply to this initial random population? Okay, so thank you for your attention. I hope you find this video interesting and important for you. And the next class we're gonna develop the selection function to apply in the crossover in to apply this in the genetic algorithm that we are developing. Thank you again and see you in the next class. Bye.